Good morning, world. Good morning, guys and gals. Hope everyone is fine and fit this morning. Beautiful day in Blighty, in England today, which is where I'm based. Sun is shining, the birds are singing, and nice crisp day. A little bit wet, but all good. So, thought I'd have a look at this really nice laptop that I've got. No power, no nothing, no life. It's a Asus, let me find the model, x1500e, and if we can get the camera to focus, it is on there somewhere. So, pressing the power button on here, just no signs of life at all. No nothing, no nothing, no screen, no keyboard, no whirring. Just absolutely lifeless. Let's have a quick look with the power meter. I'm still waiting to get the on-screen, this one here, which is my power supply, rigged up with the cabling. So I'm still working on the tried and trusted, very old and somewhat janky power supply, just with my current and voltmetering. So already selected the right end for it, so I'll pop that on there, and we'll pop this in the charge DC plug at the side, just there. So we're running on 19 volts, if we can see that. I know there's a bit of flicker with the camera maybe, but it's pulling absolutely zero current. 3 zeros, which is as close to zero as we could get. So I would say, yeah, that's no life at all. We will just double check that we are pulling voltage. Oops. And as we can see, trying to do this with the wrong hand, it's down there somewhere. 19.5 volts. I have just reconfigured this, so I'm hoping the new software I've just installed for the BIOS on the unit is reading correctly now. Have a quick drink of tea. Coffee in the morning, tea to keep it going. Always nice, or a good quality cup. I have changed the layout a little bit as well of the screen. I've been playing with the setup. So now we've got, if you've never done this, you'll not appreciate how hard this is. So we've got the current meter, power supply, whatever. We've then got multimeter. We've then got, scope, and last no means least, we've got thermal camera, which waving me little fingers in front, if we can call them. There we go, get camera's focus. So anyway, going back to matters at hand, which is why we've all tuned in. See the next enthralling episode of Let's See If We Can Repair a Computer. So, as we've already said, there's no current draw at all on the meter. 3 zeros. So what do we think that is? I'm thinking, let's try it with the power button. Just press the power button now. And again, 3 zeros. Laptop's absolutely stone dead. So nothing on the power button. No pre-charge, no LDO, no nothing. Nothing. So we'll just unplug this and move this out of the way, because that's not going to be of any benefit. I'm thinking if we have power coming in here from the DC port, if it's not getting to anywhere on the board and triggering anything, I would say the first thing we need to concentrate our endeavours on is the DC port itself. And from there, yeah, it's looking pretty good. It's a nice tight fit. There's no real wobble on the plug. Goes in. Yeah, there's no real wobble on there. Doesn't feel like it's faulty, but you never know. Never know. Manufacturer date on this is November 23, so not an old machine at all. So let's investigate a little bit further. The iFixit screwdriver, using the kit. Really nice kit this, if anybody's looking for a screwdriver kit. I can't remember what this particular one is called. It's the larger bit range out of the kit. I would say probably 90% of the bits in there I've not used and probably will never use. There's only probably about 6 or so that I use on a regular ones, which is obviously the crosshead Phillips ones here. Maybe a flat slatted one every now and again, and a couple of the Star Talks as well. What does come in handy occasionally, or I found does come in handy occasionally, is the little socket bits that you get with it, because these are ideal. That's the size for the desktop motherboard standoffs. So that's a handy one as well, certainly because it just pops straight onto into the screwdriver, and you can do it as that. So I've got different size screws on here. Always important to kind of remember where they go. So we have 3 different sizes here. So we've got small, medium, and grande. Is that large? I don't know. So it's just important just to keep track. Small ones came from bottom row, 2 large ones came from the top, and then the medium ones came from the rest. Quite often, not always, but quite often, you do get a slightly larger screw like that one in the sides. And this is just because they're going through hinges, hinge plates for the screens and things like that. So we'll talk to the case nicely, we'll whisper in its ear, and we'll see if we can get the back of the case off. All the screws are out. No hidden screws. Wonderful. Might need our metal tool just to start it off. A little bit of encouragement. Trying his best not to cause any damage. Plastic is good, but it can. We'll just keep that one on the floor for safekeeping for next time. Here we go. The seam is down the edge. There we go. Got it started. And just a little bit of a tickle. And then what I like to do, I use my fingers as a stop guard so it can't go in too far. Maybe, I don't know, 1 millimetre, 2 millimetres, something like that. And just run it round, and you can just hear the clips popping off. And then just fingers in. Get a nice feel with the fingers, just to see where everything is. If you haven't taken a laptop to pieces before, it is just a case at feeling what's right and what's wrong with the case. Some cases come off relatively straightforward and easy, covers. Some are a little bit more, well, a little bit more than they should. But yeah, so you've got a nice cover there. So we'll just put that to one side for safe keeping. So looking at this motherboard, I'll just see if I can zoom down a little bit, just so we've got a bit of... Might be enough for us. We'll just get a pokey thing to point. So just pointing out a couple of the main things. So we've got obviously CPU under there, main fan, Wi-Fi card, which you can tell with the Wi-Fi antenna. This one's got a M2 NVMe. No RAM, so RAM's obviously going to be fixed onto the board. I would imagine probably on the other side because I can't physically see it on this side. Obviously, battery, heatsink, and we've got a little daughter board just set over here with a couple of USBs, ribbon cable just joining them and so on. And then we've got the hinges here for the screen. Big space here where the SATA hard drive would go. There's no there's no connector for the hard drive, but if they did go there, we have got a little flip connector there where we can put a thing in. It's also got a connector for a, presume, fingerprint, FP, fingerprint reader as well. Speakers just down at the bottom down here as well. Nice enough design. You've got your power supply here, which will be feeding the CPU. I presume that's the BIOS chip. And then you've got a couple more power supplies. This will be the power supply down here for the battery and so in. So what we were saying was the power comes across here. And it'll come into this DC port just here. And then it'll follow the tracks around here. So I would imagine it's probably going to go straight through onto the other side of the board. So I think first thing what we can do is just check, just to see if we've got any voltage on the back of this. Then this should just give us an idea. So let's see if we have power on the back side of this. So we'll just plug the power meter or the DC back in. And we'll just see if we can get this in shot also, because I've zoomed in. Look at this. We don't get this on JFix's site. He's a trained professional. So we're on DC voltage at the moment. We'll get ourselves a good ground, which will be this pad here. And then we'll just simply, should have a DC input there. And we've got 19 volts coming in. So we know it's now getting to there. And we'll see if it's just getting to the board. And it looks like it's getting to the board as well. So we'll just check one of these coils just to see if there's anything coming to these coils. And I very much doubt whether there is, because there was nothing coming across. So we now know it's that, but it's not going any further. So it could be something like a fuse or something like that to say where we are, what we're doing is not actually anything pulling across. Right, we do have 2 volts, 2.1 volts on that little capacitor there, which is what I'm looking at. We've got 19 volts, so there is voltage coming into the board. So we've got a MOSFET there. So let's I'm just going to pop this hinge off, just to give me a bit better visuals. Don't really think I need to actually. Let's unplug that and let's just check for shorts. That's the next thing we need to do. So we'll just put on continuity or beep mode. So let's get the machine that goes beep. As a great Monty Python would say. If you don't know the reference, have a look through. I think it's The Meaning of Life. Let's get the machine that goes beep. It always impresses people. Oakley dokley, as they would say. Let's find ourselves a ground. Should try flipping this over to the scope. So just flipped over to the scope now. We'll check some just for shorts on the board, just to make sure there's nothing else. So we're on the beep mode on the thing, and we'll just flick across here and see if we can just check some of these coils, just to make sure we've got no thing. So we've got 12 ohm there, 13 and 60 there. They seem a bit funny. I always presumed that they'd be sort of 2 to 5 ohms on the CPU. So 12 ohms seems a little bit strange. So we have another one down here. Yeah, open line. Got one just next to it, which is open line. And we'll just check the battery charge circuit, which is the ones down here as well. So yeah, high resistance there, 220. And I would imagine, yeah, open line on there. So apart from these ones up here on the to 12 ohm shorts, So as we can see on the meter, top right. Just readjust that a little bit. So yeah, those I would have thought should be, rather than reading about 12 ohms, because direct short is, yeah. So if we look at what the what direct short is, it's definitely 12 ohms. So I would say that they're, to me, a little bit unusual. So we had voltage on this side, which was 19 volts. Just need to see if we've got voltage coming out of it on that side. So we'll just plug the charger back in, and we'll just flick this back over to DC voltage. So this side here, which will be the output, we're outputting 19 volts. So we've got a trigger voltage there, gate voltage, which should be correct. Now, so we've got input there, sorry, do beg your pardon. And we've got 1 volt on that side. Current sense resistor. Got 1 volt on current sense resistor. We don't have an open short on current sense resistor, so we're good on that. So what's the thoughts of what this could be? 2 MOSFETs, 119 volts coming in, 1 not. So we'll just check these on. So we know this is diode mode. Yeah. Oh, half an ohm short. So do we think it's that? What's gone? Can't see the gate on there. I presume it's that top one, which goes to the back of that capacitor. My eyesight's not as good, so it's back of there because it basically comes up this track and back around. So that's the same point. 2.7, so it's not shorting to there. So gate's fine, but the MOSFET seems to be shorting half a. There we go. No, that's fine as well. Yeah, so that's all fine on there. So the 2 input MOSFETs are fine, they're not shorted. So I think what we'll do, we'll just pop this board out and we will do a bit more investigation. So I'll just magically skip forward in time with the power of YouTube and we will have the board out. And as if by magic, or the power of YouTube, we have a disassembled laptop. Just noticing it has USB-C, so just wondering whether the USB-C will power the laptop. So we'll just plug a USB-C power adapter into this. Just get the charging plug for it out of the big box of power adapters that I have, and you can never find the one that you want. So we'll just plug the USB-C meter in just to see if we've got any signs of life. And if it's alive, we need to say it's alive. And no, dead as well. Not a thing. Not an iota. So, it's not working on USB-C. That could be because it doesn't work on USB-C. Or it could just be because of the same fault causing it not to operate. We'll put our soft screen, but I'll leave it zoomed in. We have got the power back in, still reading 0 on there. We'll put the meter on DC voltage. Okay, so where was I? We were testing for voltages around the board. So we have $19 coming in there. Just let me just make sure that it's not that. 19 volts coming in there. And then by the looks of it, that goes immediately to the other side of the board. So we'll just flip the board and find an appropriate ground. So we've got a ground by, yeah, we've got 19 there. If I can just move this to a little bit faster. There you go, high speed. High speed. By lightning. So this MOSFET here, let's put that to the scope and see if we can do this under magnification. The magnification, so we can see what's going on. They've gone and put a load of white paint over this so I can't see anywhere. So it looks like this is probably where it comes up, because this is your current sense resistor just round here. So if this is where it's coming up, and we've got 19 volts coming in here, we've got nothing coming out, so this isn't being switched, so the gate is low. So nothing coming into there because that's the output for that one. You know that that's the gate, and we've got nothing on there. So it means we'll have nothing. We've got 1 volt on there, and we've got 1.1 volts there. So, little confession here, guys. I have stripped the board out, and then I thought, make a quick cup of tea, and forgot to press record on the recording software. So I'm going to backtrack a little bit and just confirm what I've done. So we've got the board out now, and as you may recall, no current or anything like that as highlighted on here. So we'll just simply unplug that. We're going to see what the issue is. There was no shorts directly showing, and we had voltages around the board, but in essence it was not very well. And then we had a short, albeit a small one, on there. So I'm just going to inject some voltage at the current sense resistor here to see what's what. So I was going to top that off at about 11 volts and give it some current. So we will get this zoomed out. I'm going to use the DC jack as our ground, and I've simply got on here my multimeter probe pin sticking out of my little test clamp for current. So we don't need that much current anywhere near as much as that, so we'll knock this down to about 2.5 amps. And we're going to go in at about 11 volts. It's on the main power rail, this, so I have tested the other bits. We've got no direct shorts to any of the lower voltages, so we're just going to go see what is. We'll knock this down to 5 volts as a just in case. So 5 volts at 2.5 amps. We'll get the thermal camera rocking and rolling. Just take the macro lens off. We're going to just inject voltage at the current sense resistor up here. We'll see if we can zoom that in a little bit so we can see. Well, the quality is going to diminish, but it'll give you a rough idea of where we are working on here. So we're going to put that in there, and we're getting no current draw there. So we'll just knock the voltage up a little. I did test this before, so I do know it kicks in at around sort of 10 volts. So we'll just knock it up a little bit more. There you go. I'm taking 200. So we'll just do this, and we'll just put that on there, and we'll just see if there's anything on the board getting hot. There are some reflections on here, but there is something there getting a little bit toasty. So we'll just pop the macro lens on, which is here. We'll inject voltage into the same place before, and as you can see instantly that is getting a little bit warm around there. Okay, so we know roughly where it is, which is here on the board. So we'll just flick over to the scope, and we'll get this looked at under the scope to see what's what. So the thing what's getting a little bit toasty under there is that little IC chip just there. Well, we'll zoom down and we'll have a look at what that IC chip is. We'll just make sure we've got no shorts around there. I'm just going to zoom down all the way. When I say zoom, I'm going to move this little metal thing around and focus it in. Okay. So because I'd done some of this offline, it has got some residue where I was just testing it earlier, so we'll just ignore that. So we'll just check round there just to make sure we've got no shorts. Put my probe tip back in, my scope in the meter. We'll just disconnect. So we'll just get ourselves a ground again. We'll get the machine that goes beep, and we'll have a go at just making sure we've got no that'll be ground at that side. So when I did the tests earlier, I couldn't actually find any direct shorts around this. So just remember, when we plug the meter in, I'm not actually getting any current draw and it's not switching on. But that's the little chap there which is heating up. So we'll just give that a clean and just see if we can read the number on it, which is 8237. Let's put this the right way so we can read it the right way up. 8237. So we'll just have a go at taking that off and just see if it rectifies the fault. So we're going to use the Atan air station, the ST862D. I want it off pretty quick because there's a plastic connector and quite a swollen cap near it, in fairness, which is that one there. So it's a bit bulged compared to its friend next door. Just put that look a bit bulged to you? What they should look like? Certainly not looking well, is it? Look a bit fat. Does it look like it's at all the pies? Not sure. They're the good ones. That's certainly a flat one. Looks like it's holding its Christmas weight a little bit. Not sure. But anyway, we ain't got a current draw with that in. That's the thing which is getting hot under a little bit of voltage injection. So we'll run this onto off pretty quick. So we're going to run at 450 at 25% air. We'll just warm it up a little bit first. Put a little bit of heat into the board. It's not an ultra thick board, this one. We'll grab it with our little tweezers and we'll just apply a little bit of warmth. Give it a little bit of a toast, and let's see if we can just remove it from the board. And as if by magic, the little thing has been removed. So I'll just put that on the side. So the offending article is there. I'm going to put this to one side so we don't lose it. And it's a bit warm, this board, so we'll just put it in front of this fan for 2 seconds just to cool down. You'll have to excuse the noise from the hot air station. It really does ramp up when it gets going. So that was raising to about 40 to 50 degrees. We'll have a look what that chip does in a second. The board's now cooled down. So we'll have a quick look to see what this chip does. Now, according to our friends on Google, it is an Intel 8237, which is what that chip is. It's a direct memory access controller, and it's part of the MCS85 microprocessor family. Let's see if I'm looking at the right thing, and I don't believe I am. But it is right next to the SSD slot. I believe it's this one, 8237A. Or it could be something completely different. But that's the little offending article which was overheating. Yeah, they're all come up as a DMA, direct memory controller. So what we're going to do, we'll switch back to that and we will see if we've got any current draw now on the power supply when we plug it in. So remember, when we were plugging the power supply in, we were getting absolutely zippity-doo-dah, nothing at all. So we'll see if we get anything now. Looks positive. Don't know if you can see that, but we're getting 0.8, 0.8. Looks like it's going through some type of boot sequence. Sat down at some type of static volt current draw there. Let's just check, because we had on these, we had odd resistance showing on those. So let's just see if that, it was about 12 ohms from memory. That's gone down to 6 now, and it was at 12, which is more in line where I would think it would be. It was showing 12 ohms before, it's now showing 6. This was showing 12.2, I think, and again showing 6. I think that was showing about 30. So I think, because all these are in very close proximity, I think that may have been the offending article there. So obviously you've got a direct shot on the ground pad. Let's get the scope back on. So we've got ground there, which is ground. We've got a test pad there, which is open circuit. We've got another test pad coming to this pin there, which I presume is pin 1, open line. This one goes to the back of this. Yep, 87, and that one there, I think I'm touching ground. That's earth ground as well. This one goes to here. Yeah, kilo ohms. Oh, yeah, 100. And then we've tested that one. So it does look like it could have been that. Just going to flip this over and have a look on the back of the board to where they come out. It should be 2. So these are the 2 vias, which are the ones which come through the board here, but neither are touching, so there must be internal grounds just there. I'm just wondering now if because if this is the controller for the SSD, which is what I'm believing it is, whether somebody's tried to change the SSD and maybe left the battery in or something. Oh, this is going to screen, isn't it? Not the SSD, this is screen. I'm thinking SSD because it's there, but this is a screen driver of some description, because this is the power for the screen. So we're going to get ground obviously there. Let's put it back on beep, because we like the beep. And then that's obviously ground there, so this is going to be positive for there. So I'm thinking that maybe there's been an issue with the screen or something similar, which has caused this to go. So should we just plug this in and see if we've got any voltages where we should have them now? So we're just going to DC voltage again. We'll find ourselves a nice ground and we'll just see if there's anything coming on. There were these MOSFETs up here before. That's actually pulling now 0.7 on my current. We had 19 volts on here before. Got 19 volts now. Is this side coming on? 19 volts. I can feel the CPU getting warm. 19 volts. It looks like the board now, because that would something like a volt before. I think the board is definitely booting. So I think this controller, whatever it is for the screen, may have caused maybe the culprit. What's caused it to blow, I'm not sure, but let's get the screen, let's get the machine back together, and I can always try it with HDMI to see if it does rectify it. I'm just going to try popping it back in its case and seeing if we can get any type of. I don't think the display side will work, but you never know. I'm not going to bother about connecting too many things up. Only the bare minimum. So we'll have a go with the keyboard. We will plug the screen in. Not going to bother with the battery at this stage. Just going to bother with that, and that's about all. So I will just try plugging that in. Definitely pull in some current. Maybe a few raisins. I'll put the well, that's interesting. I pressed the power button and it's certainly going up with just peaking below just an amp. It will have reset the BIOS, so it's gone down to 0. Power button is reacting to it. And it's sitting at 0.74. Right, that's static current, that. Oh, 0.75, 76, 77, 76, 77. Won't get a job as a bingo caller. Seem to have some type of static voltage there, so we'll just pop that out. Shall we go with the screen disconnected? And let me just try a HDMI on here. I'm not geared up for trying a HDMI on here, so I am wondering how I can connect this up. So we'll try one of my. You won't be able to see this, I do apologise, but it's like watching football on the radio or soccer on the radio. It's always exciting. It's all down to commentary. Or it's all down to an explosion, what you can hear off camera. I'm going to plug the HDMI in and see if we get a picture. It's a right riveting, watch this. I'll tell you that now. Okay, So we are peaking at that, and we've only gone and got a picture. I wish I could show you, but we've got a picture. So it does look like that little chip, what we identified, was the culprit. And that's what was doing it. So we need to see if we can find one of these little chips. I'm going to see if I can find one of these off camera, because off stream, mainly because it might take a little bit of searching. But if anybody can help with this, we'll just show you which one it is. Just get this focus down. It's the one what sits there. I'm doing my very best not to drop it, hide it and lose it. It's an 8237. And it looks like that underneath. So we've got 6 pins in a centre pad. And it looks like it's some type of driver or controller for the I'm just going to try and focus this a little bit better to see if anybody can fully identify it, but yeah, 8237 looks to be the number on there. 8237, and I believe it's on the it's for the screen, because we can see the power, so it's probably the power IC or something like that, power controller or something with the screen to do that. And it's switching, which meant for whatever reason it was bringing the resistance on those 2 coils, which I presume fed the CPU, to quite high away from where they should have been, which were around 5, and they're now reporting a 6. The machine is posting to that, but it's not working on internal screen. It's only working on HDMI. So it looks like this fella has fallen at the first hurdle and died. So what we'll do, we'll park this to one side. We'll call this partially fixed, because I do need to order a part, and then we'll revisit this at some stage in the future. But a good one on that one. Found out what it was, managed to remove it, managed to get it to post, and work from there. So what I am going to do is just quickly reattach that, just so I don't lose it and we remember where it's gone. Because the last thing we want to do is put something down and not remember where it went. So we'll get our it's not going to be, so this is just going to be to as a placeholder rather than anything else. I did take a picture in situ just to make sure we get it the right way. So let's just make sure I get the right orientation. So pin 1 is this top right hand corner. Pin 1 should be denoted with a little dot. She's there, I can just see it on camera. So I'm just going to hold that in place. I'll just pop the board out a second, because I don't want to be soldering whilst I'm, sorry, hot airing whilst it's in chassis, just to be safe. And then we'll pop that down there. and we will if anyone's wondering the size of this, if I just use a biro nib just to give you a ballpoint pen, so we're looking probably about 2 to 2.5 millimeters across, something like that. So we'll just sit that in its rough location. We'll get the air station back on. I don't want to be blowing things about, so I'm not going to give it a great deal of air, and we'll try as steady as I can with a steady hand. Just to tack this back into place. I'm only wanting to hold it in place so I don't lose it. There we go. I've not bothered using any low melt solder, any leaded solder, sorry. It's just to hold it in place. Pad next to it's gone liquid. We'll just give that a cool a second. There you go. That's just held it in place nicely, just so it's not going to go for a walk and we're going to lose it. Yeah, nice and firm. Just going to put that in front of the fan for a couple of ticks, just to take a little bit of residual heat out of it, but not doing it too quickly. So again, we're going to call this a partial fix, because whilst it's not actually fixed, that off, new one in, and we should be back up and running. So I'm going to search the internet for a replacement, and we will post a part 2 where hopefully we'll get the chip, fit the chip, and have it all up and running and working. So thanks for joining us, guys. Please smash the subscribe and like button. Subscriptions are really important for me to know what I'm doing. There's people out there wanting to watch, and obviously the like button is just an appreciation on that, and I really do appreciate everybody who's joined, liked and subscribed already. Big thanks out to JFix, James, who's a super guy, who highlighted me on his channel the other day and give me a shout out, and also Tony at Symbol Tech for all the help and advice he's offered as well, and all the other creators out there and small creators who help in the communities. It is a good community, and we all really do appreciate the people who are spending their valuable time watching, listening and helping, and all the help and advice that I can get is really much appreciated. So thanks again, guys and girls. Please stay safe, have a good day. Just remember, if you enjoy what you do what you enjoy, you won't go far wrong. Have a super day, and speak to you in part 2 or very soon with other videos. I do have some projects coming and some unboxings. I've been hitting AliExpress, so got some of those coming over the next few days as well. So speak soon. Cheers, guys.